Hello students, in this video I'm going to give you an overview of the distribution of sample proportions. First, we're going to compute the mean and the standard deviation of the sampling distribution of sample proportion, and then we're going to talk about the relationship between the sampling distribution of the sample proportion and the normal distribution and the binomial distribution. Assume that in an election race between candidate A and candidate B, 60% of the voters prefer candidate A. If a random sample of 10 voters are polled, it is very unlikely that exactly 60% of them, which is 6 out of the 10 people or voters, prefer candidate A. By chance, the proportion in the sample preferring candidate A could be easily a little bit lower than 60% or a little bit higher than 60%. The sampling distribution of sample proportion is a distribution that would result if we repeatedly sampled 10 voters and determined the proportion p hat that favored candidate A. Meaning if you have a population, and in this population we have 60% prefer candidate A, repeatedly poll samples of size 10, let's say 1,000 samples, and then compute the proportions of people who prefer candidate A in each of these samples, you're going to get multiple p hats. That p hat could be 70%, it could be 60%, it could be 50%, and etc. And then we're going to put these p hats together, and that's what we call the distribution of sample proportion. Here is an example. Let's say we took a sample of 10 voters, and we asked them if they prefer candidate A or candidate B. This table shows the results. Basically, this is the rough data or the raw data that we collected. If the voters said they preferred candidate A, we put 1. If the voters said they prefer candidate B, we put 0. 1 just means yes, they prefer candidate A. 0 means that they don't prefer candidate A. It has nothing to do with positivity and negativity here. 1 doesn't stand for the number 1, 0 doesn't stand for number 0. It's just a binary system to see which candidate is which. And then we computed the proportion of voters who are going to vote for candidate A or prefer candidate A. And then we counted the ones. We had 7 out of 10, which gave us p hat is equal to 70%. As you can see here, we can assume that p hat is the mean of the 10 preference scores. As you can see here, 7 out of 10. That's exactly how we find the mean. Now keep this in mind as we progress. The distribution of sample proportion is closely related to the binomial distribution, as you saw. The binomial distribution is the distribution of the total number of successes, as we learned previously. We will be given the sample size and then the probability of success. We build the table and then answer the questions related to that. The distribution of sample proportion is the distribution of the mean number of successes, as we saw in the previous example. The mean, of course, is the total divided by the sample size. So that's how we're going to derive the mean and the standard deviation from the binomial distribution to the distribution of sample proportion. The sampling distribution of sample proportion and the binomial distribution differ in that p hat is the mean of the scores, 70%, and the binomial distribution is dealing with the total number of successes, which is 7 successes. Now, we know that the binomial distribution has a mean of n times p. And we know that the distribution of sample proportion is the mean of the number of successes. So all we need to do is we're going to divide by n to adjust for the fact that the sampling distribution of sample proportion is dealing with the means instead of the totals. We find the mean by dividing by n. So we're going to get the mean of the distribution of sample proportion is equal to n times p divided by n. N is going to cancel with n, and we're going to end up with p. So the mean of the distribution of sample proportion is equal to the population proportion. P is the population proportion. The standard deviation of the binomial distribution is given by this formula. And again, we're going to divide by n, lowercase n, because p hat is a mean, not a total. So when we divide by n, if you divide this formula by n here is outside of the square root. In order to make it go inside of the square root, we have to square it. Just like when we say 2 is outside of the square root, but this is equivalent to the square root of 4. So we have to square it in order to put it under the square root. So that's the next step that I did here, is to include the denominator under the square root and then square in the n. You notice here that this n is going to cancel with one of the n's at the denominator, and you're going to end up with this formula. Meaning the standard deviation of the distribution of sample proportion is equal to the square root of the population proportion times 1 minus the population proportion divided by the sample size. So this is n, and I saw another mistake. This is p hat. Returning to the voter example, we have the population proportion, 60%. We have the sample size, n is equal to 10. Please don't confuse p with p hat. P hat is the sample proportion. The sample proportion, usually we use p hat for that, is basically when you take a sample out of the population and then compute a certain proportion. Therefore, the mean of the sampling distribution p hat is going to be 60%. That is because of the previous formula. So the mean of the distribution of sample proportion is equal to the population proportion. And the standard deviation, we're going again to use the formula, which says the square root of p times 1 minus p divided by n. So n is 10, p is 60%, and the answer is going to be 0.155. So this is how we're going to compute the mean and the standard deviation for the distribution of sample proportion. Now that we have the mean and the standard deviation, let's see if the distribution of sample proportion is normal when we're going to be 100% sure that it is normal and the application of that. So the sample distribution of sample proportion is actually discrete rather than a continuous distribution. For example, with an n equal to 10, it is possible to have p hat is equal to 50% or 60%, but it is not going to be 0.55. Because if you return to this example right here, what is the chance of getting 0.55 if you can only have 5 ones here, or you can only have out of 10, or you can't have 5.5. So that is why it is discrete. It is considered discrete distribution. It is not a continuous distribution. However, the distribution of sample proportion is approximately normal, especially if we increase the number or the sample size. So if the sample size is fairly large, you will see that the distribution is going to take a bell shape. That means we can use the normal distribution in order to approximate the distribution of sample proportions. Here is the rule of thumb. The distribution of sample proportion is approximately normal, and we can apply the rules that we learned about the normal distribution if n times p and n times 1 minus p are larger than 10. That is saying n times p times 1 minus p is greater than or equal to 10. So if this rule applies, we can apply the normal distribution rules. We can say the mean is equal to the population proportion. The standard deviation is equal to the square root of the population proportion times 1 minus the population proportion divided by the sample size. Otherwise, if n is small, sometimes we have to resort to the binomial distribution to answer any questions related to the distribution that we have, because n is small and we can't use the normal distribution. We can't be 100% sure that the distribution is going to be normal. So we just use the binomial distribution because this is a discrete probability distribution. Let's look at some of these questions and try to answer the question. The binomial distribution is the distribution of the total number of successes, whereas the distribution of p hat, or the distribution of sample proportions, is it the distribution of the mean number of successes, the distribution of the total number of failures, the distribution of the ratio of successes to failures, the distribution with a mean of 0. So I can right away eliminate all of these. And the right answer is the first answer. The distribution of sample proportion is basically the distribution of the mean number of successes. The second question, out of 300 students in a school, so that is the population is 300, 225 passed an exam. What would be the mean of the sample distribution of the proportion of students who passed the exam in the school? So in other words, it's asking about the mean of the distribution of sample proportion. In this case, we're going to say that is basically the population proportion. And the population proportion is the part over the total of the number of population. So that is equal to P. P is equal to 225 divided by 300. And that proportion is going to be 75% or 0.75. So that is basically the mean, because in this distribution, the mean is equal to the population proportion. Question number 3. Out of 300 students in a school, 225 passed an exam. You take a sample of 10 of these students. What is the standard error for p hat? Okay, so to find the standard error or the standard deviation, we know that the standard deviation for the distribution of sample proportion is equal to the square root of p times 1 minus p divided by n. We know that p is equal to 0.75 from the previous question, and we have n is equal to 10. So we do the math. 0.75 times 0.25 divided by 10. 1 minus 0.75 is 0.25. And then the answer is going to be 0.1369, rounded to 4 decimal places. So this is the standard deviation or the standard error of the distribution of sample proportion. I hope this video helped you understand the distribution of sample proportion. Thank you for watching, and I will see you in another video.